over a few admin items. This webinar is being recorded, so if for some reason one of your colleagues isn't able to join, I'll be able to send them the link. And for the duration of this webinar, we are going to keep everybody on mute. So if you have any questions or comments, please type them into the question and answer portion of your panel or into the chat portion of your panel, and we'll respond to you that way. But for now, we're going to get things started. I'm going to hand things over to Joan Glickman.
Great. Sorry, I'm just moving the phone. So thank you all for calling in. We really appreciate it. Let us know if you're having any trouble with audio. Hopefully it's clear. So I'm just going to go to our next slide. Do I have control or not? You can just go. So today's presentation, as you know, primarily I think we kind of marketed this as something we're going to talk about PV, the inclusion of PV in the 2017 update to the home energy scoring tool, and that is the majority of the presentation, but we're also going to tell you quickly about the other updates we're making to the tool, which is coming out in January. And so that's basically a quick overview of what's happening with the scoring tool, what's going to change, and Glenn will do that for us, and then he'll turn it back to me, and I'll talk to you about how we've decided to credit PV in the scoring tool and what your assessors will need to do in terms of collecting data. Okay, so I'm going to turn it over to Glenn. Thank you.
Thank you, Joan. Mostly this is just so Joan doesn't have to talk through the whole presentation, and I think most of you probably know a lot of this, but we will launch the new version of the tool on January 17th, 2017. We will call it version 2017, remarkably. The primary changes are that we're going to add the solar PV, which of course Joan is going to review and explain how we're incorporating that into the calculation methodologies. We'll also add the ductless mini-split HVAC system, the evaporative coolers or swamp coolers for our desert Southwest people. And then there are a few other changes that we haven't talked quite so much about, but we're also incorporating. We're changing the source-to-site conversion, site-to-source conversion factor for electricity from 2.76 to 3.14. This more closely aligns with the sort of the trend and the way the grid is starting to transition with more renewables being added. So it's a better number for that value, and we believe it'll help with the score comparisons for gas heated versus electric heated houses. And in the process of it accounting for that, we've changed the scales. Since the scales are based on those source numbers, the change in the source factor has changed those definitions, so that's being incorporated there. And a couple other minor things, some minor changes to the duct leakage assumptions. What we've been using are probably a little tighter than what you typically find in existing homes, closer to what you would find in new construction. So we've adjusted those a little bit, and we've lowered the cost of air sealing a little bit to what we think is a little more in line with what the industry numbers are. What we have in our existing database looks a little high, so we've brought those down a little bit. That may show those recommendations a little more often. So that's my little piece of the pie, and I'll turn it back over to Joan for the meat of the conversation. Thank you.
Thanks very much, and Glenn's been involved in all of it, so we really appreciate all your hard work. If you have any questions, I should have mentioned, I should have put this in the slide and I forgot, that the change in the source energy conversion factor to 2.76, that's also documented in a piece or an article or a publication, I should say, that EIA put out of DOE, I think just like 2 months ago. So it's consistent with what they're saying is another way to deal with the site-to-source conversion, as Glenn already explained. So if you want more information on how the 2.76 is calculated, we can send you the link to that paper. Okay, so as I said, the majority of this presentation is really on how we incorporated PV, because the other things were a lot more straightforward. And the reason that we have gone forward and including PV now as of next month in the scoring system is that, as you all know, there's growing interest and growing use of PV on homes across the country. Obviously, it's more common in certain states than others, but there's certainly been a lot of marketing of the product and a lot of uptake in the marketplace. And so we basically want to make sure that since it's an asset that's part of the house, it's considered as part of the score. And we also realize that one of the ways that we want home energy score to be used, not exclusively, but certainly one way, is at point of sale. And realtors for some time have viewed PV as an attractive feature for homes, and appraisers have ways that they can value the PV. So it really made sense to kind of be in line with what people are already seeing at point of sale, that PV is certainly something that conveys with the house. You're not going to take down the panels, I would imagine. And so it's something that should be included in the score, given that we're trying to include the vast majority of things that would convey with the house that have an impact on energy. And I should mention this, but I think it's also in later slides. The scoring tool will not automatically generate a recommendation for PV, but if a home already has PV, it will allow you and ask you to include that in the assessment and scoring of it. And it also, just like assessors can override our recommendations for energy efficiency improvements, they will also be able to add PV as an upgrade should they, want to include that, whether it's, one of our current assessors or, if there's a PACE program out there that's doing a lot of PV and they want to use the score with that, it's certainly something that they can add separate from the DOE recommendations, but it can still come out and be credited to the upgrade score. Okay, next slide. So the benefits of adding PV are, in addition to what I've already said, we also recognize that there's a lot of interest in a number of states and cities, and as states and cities write their own policies about how to do labeling, some of them are specifically noting that they want PV to be included. So I put Oregon in there as an example, Berkeley is another one, and Vermont as well. So there's a number that are either currently have policies or are adopting policies that want to look at energy labels, and they consider it not just efficiency, but they also consider it to be renewables at that home, on-site renewables, I should say. We also recognize that there's a number of cities that are really working toward not just, efficiency, but have zero carbon goals or lower carbon goals in mind. And so this is obviously something they're going to be using. And as I already said, realtors like PV generally, so it's something that we want them to be able to credit to those who invest in it when they're selling their house. It also, I know that some of you have been frustrated at times that you'll have a house that scores a 1 or a 2, and due to, a variety of factors, whether it's the way it's been built or the way it's, some structure, or just the fact that some efficiency improvements might be extremely costly, you'll get an upgrade to score, that's still below 5. In some cases, it could be just as low as 2 or something. So, or I think a rare circumstance, maybe even 1, but I hope that's rare. So in those cases, it is really nice to have other options. You can always include additional recommendations for efficiency and go beyond our recommendations, which obviously could improve their score, but you can also, I'm sorry, there was an interruption. This way you can also include PV as something that folks can invest in and have a way to improve their score. Okay, I think next slide. Sorry. And so when we looked at different ways that we could credit PV in the score, we actually evaluated a number of different ways to do that. And it's not, quite as simple as just saying, here, we're going to calculate it, and now it's obvious how that should be credited to the score. So we wanted to do something that was obviously transparent and easy to explain. And I will say that the documentation for home energy score, we've always said it was transparent, but it was sometimes hard to find that documentation. It is much easier to find now, which I'm pleased, on our website. So this will also be included in that as we go forward in January. So I think the method among those that we analyzed is perhaps the most straightforward, or one of the most straightforward to explain if a homeowner asks you how it's being incorporated. We think it sends appropriate market signals. Now, people have differing views on this, obviously, but here at the Department of Energy, we obviously do care a lot about efficiency. The program I'm in is called Energy Efficiency and Renewable Energy. So obviously it's a nice big half of what we do here. And the feeling is that you're always using resources. Even if you're using renewable resources, you're still, putting in panels or whatever it is you're doing. And so we want people to look for the most cost-effective way that they could save energy and reduce their footprint. And so you can do that both through efficiency and PV. So we didn't want people to just be able to, put PV on a really very inefficient home and suddenly get a 10. So that's something that we were trying to do in terms of sending the market signals that we thought would be appropriate. Still encourage PV, but also encourage efficiency. And we think it's also appropriate for what the purposes are of the home energy score. It's not a code compliance tool. It's not suggesting how PV should be incorporated into code. It's just providing a fuller representation of what that home has to offer at point of sale and what's going to go to the future, to the buyer of that home. Okay, next slide. And I'll just remind you, as Maddie said, if you have any questions, please type them in, and we'll try to either do them as I'm speaking or probably more likely at the end. So here is an example of how, this is the calculation method that we chose. And there's one sample calculation down there that you'll see is very basic. I chose the numbers specifically so it would make the math easy. But here's what we do. So if you're going into a house, the tool will now, you as an assessor or your assessors would go in and they'd say, okay, this home has a PV system that's 4 kW, and it's oriented south or west or whatever. This is the age of the system, and it also will know the home's latitude based on where it is. So it's using PV watts, which is a very well-recognized tool that was developed, I believe, at NREL. And so it's calculating how much PV or how much kWh production you would get from that PV system based on its size, its age, orientation, et cetera, and where it's located. Then the tool will convert that kWh value into source MBTUs. And what we mean by that is the kWh basically is converted directly into MBTUs. You're not having any conversion losses, or I should say any distribution losses from going from a central plant to the house. So we're not multiplying by 2.76 in the case of this electricity because it's generated on site. Then the tool will deduct that MBTU number. Basically the kWh just strictly converted into MBTUs. Take that off of the Home Energy Score's acid energy estimate. If you remember, that's the MBTUs that are associated with heating, cooling, and providing hot water to that house. It's not MBTUs associated with plug load, lights, etc. And then based on that new MBTU number, you will get a new adjusted score that reflects the home's energy asset. So I gave you this really simple calculation here. Let's just pretend there's a house that miraculously comes out to be an estimate of 100 MBTU for heating, cooling, and hot water. It has a system on its roof, and it's generating this much kW. It's generating, I'm sorry, now I've forgotten what I said. It's generating 2931 kWh, and that is converted to MBTU, which is 10 MBTU. So you take the 10, you subtract it from the 100, and you end up miraculously with 90. So you got 90 MBTU, and depending on where you are in the country, you look on this, well, you don't look, but the scoring tool will associate that with the correct number on the 1 to 10 scale. So, maybe it would have been a 5, and now it's going to be a 6 or something like that. Okay, next. Okay, so whenever we do changes to the scoring tool, particularly things like this, where you're actually changing a specific scoring method, we do a lot of analysis. So if you remember, back when we changed, we made a lot of changes, I believe it was in 2014 and then some in 2015, we do a lot of analysis. So we looked at a variety of different, as I said, a variety of different ways that you could adjust for the fact that a house has PV. We took about 6,000 homes records that we had from our database. So these are homes that have been scored by all of you and your assessors in the field. And what we found from those 6,000 homes, and these were just basically Glenn pulled, the last 6,000 or something like that. Based on these homes that covered about 22 states, not, obviously in a representative fashion, but that's just where they were located. Those homes, if they were scored today, they could improve, or when they were scored, they could improve 2.3 points on average from efficiency alone. And then we made estimates of how much PV could be on those houses based on what we could see about how big they were generally, the square footage of the home. So we made some assumptions about how big a PV system people might put on, depending on the conditioned floor area. You'll see those broken down below in that chart. And basically what we did is, based on the size, we added the PV, and then we did additional analysis to see how much PV credit would be given, how much it would change the score if you looked at the PV from a variety of different ways. Excellent. So when we did that, we got lots of different distributions and found that, those 6,000 houses would score a variety of different ways, obviously, depending on how you were crediting the PV. And it was basically like a Goldilocks thing. If you do it one way, you're going to give them way too little credit, and the PV won't really change your score at all. If you do it other ways, pretty much everything scored a PV, whether or not they did efficiency or not. And we didn't think that was really the right message that we wanted to send people. And then there were some methods that we even didn't do because they were just too complicated to calculate in the tool, or were too complicated to explain, and we did do those, but we found that it was going to be almost impossible to figure out ratios and then explain that to homeowners, and it would not necessarily treat every house the same. If you have the same size PV system on two different houses, they may not credit the same, even if they're in the same area. So we didn't like that. So there were different ways that we looked at, and then ultimately came up with the calculation tool the calculation that I just showed you on a couple slides back. Next slide. So the next few slides, the next couple slides, show you what we found when we did these, when we applied the methodology that we came up with, the one that I gave you the example of 100 minus 10, came to 90. And what we found that if you apply that methodology to these 6,000 homes based on, different size systems, based on their square footage, the PV systems on average helps these houses jump 1.5 points alone. If you didn't do the recommendations of efficiency, it would give you a 1.5 increase. And so these are still the same houses that could increase, I think I said this earlier, 2.3 from efficiency improvements that our tool was coming up with that was saying those were cost-effective efficiency improvements. So you'll see that basically, there was a decent spread. There were a few that, 21 houses could actually jump 6 points. I'm guessing those were massive PV systems, but the vast majority, were somewhere in the 2 to 3 range. And obviously, once you averaged all out, it came to 1.5. Okay, next. And then we also looked at those same 6,000 houses, more or less, and the reason I said more or less is in some cases we didn't have full records for certain ones. But what we did was we looked at the homes currently. Then we looked at the improved score, which you see here on the left in the blue. Hopefully it shows up in blue in yours. And that's the distribution of the scores of those homes, so more or less 6,000 homes, if you applied the cost-effective energy efficiency improvements that our scoring tool recommended. Those may not be the recommendations you guys are giving, but that's what we could use to calculate. So it was a nice distribution. It's kind of what you expect. You basically see a bell curve that's shifted to the right because these homes have been improved. But if you then add the PV system to it and see what the distribution will be, you obviously have a vastly higher number of 10s and 9s and 8s, combination, I should say, of those high numbers once you've been able to add the PV. So, and you also have far fewer, if you look at the left versus the right, the ones on the right in the green that show the PV being added, now you've gone to, it's still not great, but there's 32 that are still stuck at a 1. as opposed to 133. And so the whole idea that, yes. So the idea is that you'd still do the efficiency, hopefully, and then you'd apply PV, and you'd get credit for both, and hopefully, instead of having a 7, or more or less a 7, with no PV, you could now get an average score of 8.7 if you're one of these 6,000 houses, or the average of those. So basically, you're improving whether you do it with or without efficiency, but your ultimate score obviously would be better if you did the efficiency as well. Okay, next. And I should say that I think it was like 94% more or less were above a 5 after you did the PV. So then we also looked at a subset of those homes that were greater than 3,500 square feet in terms of conditioned square footage. And there were about 600 of those, about 10% were greater than 3,500 square feet. We looked at those and we pulled those out, and then we found that on average these homes scored a 3 before any improvements. The cost-effective recommendations only helps them move to 4 because chances are they were still, using a lot of energy, and there's only so much you could do that was cost-effective. Again, you could override those, but based on our recommendations, it would get to a 4. But if you also put the PV on, these homes, again, using our assumptions about how big they would be, how big the PV system would be, based on the home square footage, you'd end up reaching an average of 7. So that was a nice thing to see that, again, those houses that have been stuck because they're really huge and efficiency, maybe they're relatively efficient on a square footage basis, but they're still using a lot of energy. This is a way that they can improve their score. Okay, next slide. So just to conclude, basically, the reason we are adding PV is that we really think that existing homes need as many options as possible to reduce their energy use. They can do that through efficiency, and they can do that through renewables. It's obviously a personal choice what you're going to invest in, but we want to bring it to people's attention that this is a possibility. And if they do make the improvements, whether it's efficiency or adding renewables, we want to give them credit for that. We believe that the way we've chosen to do this, it's pretty straightforward, and you are still crediting, while you're crediting PV, you're still encouraging efficiency, because it's very unlikely that if you had a really inefficient home, that it would, score at the top of the scale even with PV, unless you're talking about a massive, massive PV system where you have a huge array on your house. Maybe there's a chance it would score a 10, but that's highly unlikely. And in general, homeowners will, well, this is a small point, but if you're doing the efficiency first, you will, or if you're doing both, you'll basically end up getting a little bit more credit for the PV because you're at the higher point in the scale, if you remember correctly. If you remember this, the distance between a 2 and a 3 is about 1.5 times the distance from a 7 to an 8 in terms of BTUs. And I can't tell you exactly what it is because it depends on where you are in the country with the numbers. But so obviously if you're, actually I think I said that the wrong way. The distance is smaller in the top and bigger on the bottom. I don't know if I said that the right way or not. But anyway, the point is that since it's smaller on the top, if you've already made efficiency improvements, you now add a PV, your system is still going to get the same number of credits in terms of BTUs, but it'll bump you up further, more quickly up the scale than it would at the lower part of the scale. Okay, and I already mentioned this, that we do not recommend PV on our own. The scoring tool won't do that, but you can certainly do an upgrade score with the PV and show that to the homeowner, whether or not they've had the PV or not. With the PV on it, it will already incorporate that into the score. If you're recommending PV along with your efficiency improvements, you will get the upgrade score, and you'll have to do it the same way you do now, where you override our recommendations and include your own. And I believe that's my last slide. So if there are any questions or comments, we actually still have about half an hour, and we can also end early, but any questions or comments, we'd be happy to answer. And as Maddie said at the beginning, if you could type your comments in or questions, that would be most helpful.
We have a couple of questions. There's one from Terry Freeman that asks, will the solar generation also come off the KWH usage? And yes, it will. And then
I apologize. Go ahead.
And then the other one, and Joan, I may need your help with this because I'm not sure I follow. What were you seeing as an impact of energy efficiency before the calculations were changed to incorporate PV? It looks like the EE improvement is less impactful on the score if the house is only doing EE and not solar. I think that goes back to what you just addressed, is that when the score starts off lower, whatever comes first appears to be less impactful because of the size of the bins. If I understood the question right.
I think the first part of the question was how much did it affect these houses, and I don't think I put that in the slides, unfortunately. It was 2.3 points on average, but can you go back, Maddie? I think I forgot to put a distribution chart of what the homes looked like before the improvement score, but basically they were shifted to the left of what they are here in the blue. And so on average, they could improve 2.3 points. Hold on a second. Okay, yeah, so on average, these homes were able to improve 2.3 points from efficiency alone. But if you do the PV alone, you'd get 1.5 on those homes because they weren't shifted up yet. Whereas if these were already improved homes and you add the PV, you'd get 1.8. But it's exactly what Glenn is saying. It doesn't matter. Whichever you do first is going to seem like it gets less credit than the second. So if you're doing them all at the same time, it all adds up to a nice picture of, basically jumping a total of, on average, more like 4 points as opposed to 2 points. I hope that made sense. I can't see the question, so can you let me know if there's others?
There is one more, but you answered it in the process of answering the previous one.
Okay. If you have your hand raised, can you type in your question? Okay, we had a question here from Sean. It says, PV is being widely applied absent of an efficiency retrofit, and I believe, Sean, you're in California. Sorry, the thing moves and I can't see it. PV is being widely applied absent of an efficiency retrofit due to the no upfront cost nature of many deals. Can you model an all-electric house with no retrofits that is only getting a PV array? I'm sorry, I'm looking at somebody's, at Maddie's laptop here because it's not coming up on mine. Yeah, you can model it however the house is. So those houses that we modeled that I forgot to put up here, these 6,000 before PV or before efficiency, those, hadn't made efficiency improvements, and you could put up, whatever system the house would allow and add that. So you can do an all electric, and we do have homes that are all electric in this bunch, and then add the PV, and you'd get whatever you get depending on how big the house is, how big the PV array is, and how inefficient it was to begin with. And I should mention, for those of you, I think a couple people are newer to the scoring program than others. Most of you guys have been doing this for a while. But just to remind you, the MBTU that you are using for heating, cooling, and hot water obviously does not include the MBTU that is there for all your plug load, and you get that number in what the scoring tool will generate. It'll generate the full MBTU, and it'll generate the whole KWH and all that. Well, actually, I just realized I forgot to put something on these slides. So one thing I forgot to mention is that although I focused a lot about how it would affect the score, but what I meant to put in these slides and forgot was that it will also, that calculation in KWH, can you go back to that slide? Oh, wait, sorry, I have the slide. Okay, I'm going to have to read the others. If you, Maddie's pulling it up. If, there, that one. That's what I'm talking about. Yeah, so if telling you how it would affect the score. And some of you who use one version of our label show MBTU. So the 90 MBTU, you could put on there. But in most cases, the MBTU you're showing to people on this label is actually the full MBTU. So maybe it's more like 150 MBTU to begin with. So now it would be 140. But as you also know, whether you're showing it to the consumer or not, it's in the calculations that you get in the report. We do calculate how much kWh, how many therms are being used for that house, etc. So when you take the full kWh for that house, which would include flood load and lighting, you would then take off the full amount that you're using in kWh here, because they're all site numbers, and then you'd subtract off this 2931 of kWh here and get whatever new number you get for kWh. And then you'd multiply that number by whatever your kilowatt hour rate is in your state to give you how much you would be spending on electricity in that home. And so I think some of you are probably not using all these features because it's not relevant to your use case scenario. But as you know, there's different versions of the label that you can use. Some of them show more metrics than others, and the tool can generate for you how much is it going to cost to run that house. Now it would do that by subtracting off the kWh for PV and give you the new figure. I hope that wasn't confusing. Okay, I'm pulling up questions again. Let's see. How do we input a PV system that has some shading? Glenn, can you answer that?
The tool allows for two ways to enter the data. One is either you have to enter the age of the system and the orientation, and then you can either enter the number of panels, at which point we'd make some assumptions about those the panel size and their output, or you can enter the actual kW being DC kW being generated by the system. So if you know what the effect of the shading is, then you'd go with the kW method.
Oopsie, sorry, I was on mute. Sean had another question here. I'm curious if a zero net energy retrofit with only PV can happen. What does that mean?
So if I'm understanding that correctly, I think the question is about if the house has all efficiency upgrades already made, can we model the house just with a PV improvement? And if I'm understanding that question correctly, that is true. If the assessor so desires, they can run an alternate EEM model of the house where they keep all factors the same and just add PV to a house that was previously modeled to not have PV, and then you can see the before and after impact that PV has on that house.
Yeah, sorry about that, I didn't understand. But yeah, it's just the same idea where if you wanted to add PV at any time as a recommendation to a house that didn't have PV, you could add it, whether you're adding other efficiency recommendations or not. So obviously if it's already that efficient, you wouldn't be adding more efficiency recommendations. Okay. And Sean, you asked for more explanation of the site source conversion efficiency, and I'm going to refer you to the EIA memo, and I believe there might be one from ERE as well, that explains how the calculation is done now, rather than using 3.14 as a national version for electricity going to 2.76. Basically, I don't know if you want to say anything about that, but it's relevant. I mean, Maddie will say a little bit about it because she was more involved than I was, but go ahead.
Yeah, I mean, this is Maddie Salzman. I answered the last question as well. And I can help a little bit with that, but probably the easiest thing would be to have an offline conversation just to get a little bit better sense of what you're curious about, because I know there's a lot of technical details associated with it that a lot of people don't care about. But basically, we being EERE as well as EIA are adding / changing how we are accounting for renewable energy generation on the electricity grid, meaning how we account for the losses associated with heat
and conversion associated with renewables, namely that we've gone from what used to be used, which was the fossil fuel equivalency approach, which was just an average of fossil fuel heat loss, and then have changed, and that was the precedent set, many decades ago, and have changed that to what's called the captured energy approach, which is just a 1-to-1 ratio, so we don't associate losses to heat with renewables. We do have losses associated with transmission and distribution. So that was a change that EERE made on a wider level a few months ago, and Home Energy Score is one of the programs that is impacted by that change, as we've mentioned in this tool. Is that everything? Or?
Yeah, I think that's enough. So, yeah, I mean, I just think if you're very interested in the details, and you did write something in here about how is PV counted against the site energy consumption, it's just what I said about subtracting off the full kWh that is being calculated by PV watts based on what you input per what Glenn was saying. You put that information into the tool, it calculates a kWh based on what you've put in using PV watts, and then it would subtract that from the kWh for the home, and that's what you would see in terms of the revised kWh. You wouldn't see the original one unless it's a new system that you're adding. I think that's all the questions, although they're tiny, so I can't read them. I believe that's everything. You can always send us additional questions if you have them, but I guess I'm going to give it like another 30 seconds, and if you guys don't ask any more questions, we're going to sign off early, which is always exciting. But we really appreciate your attention, and we really appreciate your signing in and your questions as well. So thank you very much, and we're excited to launch on January 17th, so you can start using PV then. Great, thank you very much.